Okay.
Thank you,
All right.
Doctor.
Yeah. Okay, everybody. The main thing I want done by y'all during this lesson is that I want you to continually interrupt me and tell me stop if I'm going over your head, because I will go over your head. The stuff is kind of heady at times. So do not be embarrassed to jump right in there and say, you lost me here. And the reason that this is important is because I'm trying to hone these lessons down to have a wider audience. And I need to know if I'm not reaching people correctly. Otherwise I'll go giving this lecture to another group of people, and they'll be just as lost. So I can really use your input. So there's no stupid questions. Blurt them out there. I want this not just to be some professor-student lecture. I want it to be a didactic session where we go around the room, throw questions in there, and see how they work out. Well, in any event, this is going to be oriented around a couple different papers that came out. One paper is basically a nuclear bomb that just went off. I mean, it really changes everything. And we're seeing these kinds of paradigm changing articles coming out in just the last year. It's astounding, really. I mean, we're seeing major challenges to the evolutionary theory of neo-Darwinism and at its bedrock. And so I'm going to go ahead and start off with this first article that came out. And let me see. And this is the article. I'll show you the title of it. This is, by the way, you can find, I'm guessing that most of y'all might be on my Facebook group called Darwin versus Lamarck. And I'll show you this group. Okay, and it's got almost 400 members now. But I post just about everything that I find in this group. And so you can find these articles posted with a little comment about what's going on. So this is, we're going to discuss this one article's titled Disproving a 60-Year-Old Hypothesis that most silent mutations are actually harmful. Let me see. Everybody can see my screen. By the way, I use a little app, which I highly recommend for everybody. It's called DIIGO. And if you see my mouse finger pointing at it, I've added it to my Facebook, to my Google bar up here. You see the D with the red bookmark. And what it does is it allows me to read and annotate a particular article. And now it's annotating this article as I read it. So you can see here that I've highlighted and placed this annotation in yellow. You can then go back and read now I can go back to diigo.com. By the way, this is free. Now I get the paid version, which is $40 a year, but it's because I have thousands of articles. But if you don't have thousands of articles, just the free version is quite good. And here's the highlighted article, one here, doing the theory of evolution. But you notice it takes little snippets and puts it in there so you can see your snippets. And I find this tremendously helpful because as I read every article, I don't care where I'm at, in Forbes magazine, or if I'm looking at a journal article out of Nature, I highlight everything that I'm interested in. And I'm trying to be sparing with the highlights, but then when I want to search for something, say, I'm going to search for GC bias, which we'll discuss later. notice the articles. I've got 69 articles on GC bias. Now, you would never remember that anywhere else, or even if you tagged them all and put them in a folder, but to be able to review them and see the annotations and reread that section. And what's nice about this is I can grab this shortcut right there on GC bias, and I can look it up later, so I can do certain searches on things. And it's just a tremendous tool. I've found it incredibly useful over the last 7 years. It helps me when I post things. If I post something on Facebook, I can come on here and grab a section of text. And as you notice, when I post things in Darwin versus Lamarck, I post a lot of paragraphs. It's interesting that Solomon said that he read all the books. He said, at the end of it all is fear God is the beginning of wisdom. But he did say, I searched for goads, which are chunks of wisdom. So he would read through all these books just to find one little bit of truth. And at his time, there was very little truth in things. So he was reading, a lot of stuff and not getting very much. So, but this is the goads that you can find. And there is goads in just about every paper. Even if a paper is highly leaning towards neo-Darwinism, you can find a couple facts in that paper. Okay, so much for promotion of DIIGO. The other nice thing, by the way, about that is you can share your whole library. Like if you email me and say, Dr. Manchin, I want your library, I'll send you the link. You can look at every article I have and search every one. You can't change them. So there's no fear of doing anything harmful, but you can look through any set of terms and you'll see all the articles I've read over the last 7 years. Okay, so this is the article that is the nuclear bomb. And it's talking about a 60-year-old hypothesis that most silent mutations are actually harmful. And to explain this, I'm going to go back and discuss a little bit about the genetic code. Now, the genetic code is how the DNA is arranged to translate it to protein. And, Francis Crick discovered the DNA molecule along with his partner Watson in the late 50s, I believe it was. And right afterwards, they discovered the genetic code, another group of people who won a Nobel for it. And the genetic code is basically oriented to the point that there are, well, first of all, we understand that there are 4 nucleotides in the DNA, A, T, C, and G, and that the genetic code takes those A, T, Cs, and Gs and converts them into converts them into proteins. And I'm going to show you a little GIF to explain how that happens. So what we see here, this big purple thing is a ribosome. The ribosome is made up of 2 subunits, and the ribosome sits on top of a messenger RNA. Okay, messenger RNA, in biology, you go from DNA to RNA to protein. And messenger RNA, if you got a vaccine from the COVID bug, it was pure messenger RNA that got injected into your body. And the messenger RNA turned up making proteins, which you see in the process above, the little bubbles that they're linking together. It took your own cellular machinery right here, the ribosomes, and made proteins for the virus capsule so that your body's immune system would reject it. It was actually very fascinating. The first time this type of vaccination ever occurred, it was very successful, actually, more so than they thought it would be. In any event, what we see here, you have the purple thing, which is the ribosome. Then you see those T-shaped things in the middle, and those are transfer RNAs. The transfer RNAs will carry an amino acid on its end, and then they also have a recognition site, which you can see with the letters GGC, and it matches up the code of the RNA and to bring an amino acid in conjunction with another one, and they link together. Now, this is basically the genetic code. Those sets of 3 that you see on the bottom of the tRNA, those are called codons. They're 3 nucleotides, and that's 3 out of 4 possibilities. What that does is, having 3 out of 4 possibilities, is it creates a certain mathematical aspect of things. Well, I just closed the wrong thing. Therefore, since you have 4 nucleotides, and it takes 3 at a time to make 1 codon for an amino acid, that means that your code from the DNA goes down from 64 possibilities, and that is 4 to the power of 3. And this is, you can see this in How to Read the Codon table. There's 64 different combinations, and those combinations code for 20 amino acids. Well, it's not 64 amino acids, it's 20. Well, the question is, why is that set up like that? Well, nobody knew for 64 years, and that's one of the things we're going to address. Nevertheless, it pairs down the information in such a way that you go from 64 down to 20, and that appeared to be a loss of information that was irrecoverable, that made it a bulletproof argument that DNA goes to protein and not the other way around. Protein cannot code for DNA. That is true on a certain level, but the fact of the matter is the protein can influence the DNA through its own code, which is an epigenetic code. And that adds a complete new flavor to this whole argument. If you see on the How to Read the Code. Hello? Okay, so on the How to Read the Codon table, you can see in this case the red box and the little characters that I need a theanine, could you help? And that's, of course, a ribosome reading an RNA. And basically you go, you have a 4x4 box of nucleotides where you derive the first and second letters, and you basically come down to the small red box, the THR, to pick out the right combination for this. Now, what's interesting is if you study this code box, which is very straightforward, and everyone sees this in every first level biology course, there can be many different codons for one amino acid. So if you can see my arrow pointing here, for instance, there's proline right there, and look at the number of different codons that code for that one amino acid. There's 4 of them right there. There's CCU, CCC, CCA, and CCG. All of those code for the same amino acid. So they also termed the genetic code as being redundant and also degenerate, and for another reason. But they really didn't have an understanding of why it was like this. We just accepted that, that's the way it was. And over a 60-year period, there's a lot of hypotheses, but really no one can understand. Now, what happened as a result of this is, since there's a redundancy in things, they decided to apply neo-Darwinian doctrine to this. And by applying neo-Darwinian doctrine, they basically said, well, maybe the reason that there's several codons for the same amino acid is that it protects the organism in the event of mutations. And as a result of that, that would represent Darwin's neutral position So if that's neutral, then we can measure positive or negative selection. And I'll explain a little bit further what that means. Here's an example of what that means, in fact. And there's a couple of terms I'm going to introduce to you called synonymous versus non-synonymous mutations. And as I was saying before, applying neo-Darwinian theory to this to say that those many codons that just code for one amino acid, they were assuming that because it coded for one amino acid, that mutations of these synonymous codons, if you will, was an indicative of neutral, no selection, positive or negative. But because you had a neutral position, you could then guess, or not guess, but calculate a positive or negative position. So in other words, if you had a set of numbers between -1, 0, and +1, if you know what 0 is, you can determine what 1 or -1 is by the 0. If that makes sense. Here's an example of synonymous versus non-synonymous mutations. Synonymous is just as it sounds. It stays the same. That's what synonymous basically means. In other words, if a mutation occurs and you get the same amino acid result, then that's synonymous. And you can see on the top here, you see leucine, as I got my arrow over it, is an amino acid, and it's coded for by UUA codon. And then if you have a mutation to UUG, you still wind up getting leucine because they're codons which have multiple. You can have multiple codons for one amino acid. In this case, these two codons are equivalent for coding leucine. So what they reasoned is that because that mutation can occur, this is synonymous. Now, what does that mean about neo-Darwinism? Okay, in neo-Darwinism, well, let me go a bit further about the synonymous. Here's another synonymous, is the two red ones in the middle. You have ACU, and the U gets converted to an A, but they still are both tyrosine. And then you go over to leucine again. Well, that's shown there. Now, let me go to a non-synonymous. In other words, there's a difference in amino acid. In this case, you start off with leucine. You have a mutation where the A goes to a C in the codon, and you get phenylalanine, which is totally different. That means it's not the same, non-synonymous. So a non-synonymous mutation, they realized, they reasoned per neo-Darwinian theory, is actually the mutation that drives change. Because unless you have a change in the protein, you can't have a change in the fitness of that individual. And if there's no change in the fitness, there's no natural selection acting to fix that DNA molecule. And I'll explain further. This is a simple diagram of the central dogma. The central dogma is almost as bad as the word sounds like. It sounds like a papal bull from some religious organization. Francis Crick, when he discovered the DNA molecule along with Watson, had two different theories, other theories that he proposed. And one of them, which we're discussing now, is the 60-year theory of the genetic code, in a way I'll discuss, but also the central dogma, which he paired together with it. And in this case, you can see what happens in the central dogma. The central dogma is a super simplistic view of things. Basically, it says the DNA replicates itself, and there, if you can see my mouse, there's the DNA replicator, this polymerase, which is an enzyme, replicates the DNA. However, according to theory, this polymerase would throw an occasional mutation as it's replicating the DNA. And they reasoned that this was random, and that's where improvements came through randomness, and so that fit with neo-Darwinism, right? Random things occur, and then positive selection occurs on it. Well, this all assumed on this model that DNA is fixed to RNA, and that RNA then goes to protein, and then that protein makes the individual have a bigger muscle, a prettier face, etc., and therefore it winds up getting mated with some other being, and it passes on its genes to children. And that's a simplified, just so Darwinian story, and it's based upon the central dogma. Those two things locked together seemed like it was an unbreakable argument for neo-Darwinism. And I have to admit, I was like stumped, for 30 years, because that's what I learned when I was in college. However, we now know that epigenetics sugarcoats all of this. The little tags that sit on top of the DNA, the RNA, and the protein, and how they plays out. And it takes in the signals from the environment to do this. So going back to the synonymous versus non-synonymous mutations. Oh, go down here. Okay, if a mutation occurs, according to central dogma, and it's a synonymous mutation, then this protein is not changed. So you don't get a bigger muscle. If you don't get a bigger muscle, then there's no survival of the fittest, because you have to have a bigger muscle to be more fit. Therefore, you need a non-synonymous mutation that causes a change that can be selected on. That is everyone's, well, I hope everyone understands that point, but that's the way the story goes. Okay, so we're looking for, but here's what happened as a result of that. Well, you can say, well, we can make a mathematical ratio of that. In other words, we can measure out which of these changes up here are synonymous versus non-synonymous. All we got to do is sequence the DNA, and let's throw that into a mathematical equation. And they did, and it's called the the Ka over the Ks ratio. Ka, the A in this is asynonymous, and the S is synonymous. So the asynonymous are where you have changes in the amino acids over the synonymous. So in genetics, the Ka over Ks ratio, also called Dn over D of S ratio, is used to estimate the balance between neutral mutations. Recall, if it's synonymous, that they're not changing the outcome of the proteins ultimately. So it's neutral. Or more, also as importantly, if it's purifying selection. With Darwinian, what's neat about Darwin is they get to claim everything for them. You should say that only if it's positive selection, it would be Darwin, but no, they say negative selection is Darwin too. So no matter which we go, Darwin is the one, which is a very convenient ad hoc explanation. So purifying selection basically is if when you do the ratio of the non-synonymous over synonymous, if it's in the negative range, that indicates that the organism is being selected against to take that genetic piece of information to fix it in the DNA. Now, purifying selection is a real thing. There's no doubt about that. And that's probably the best part of neo-Darwinism, because basically it is a survival of the fittest feature, but its survival is the fact that unbeneficial mutations are ferreted out because of the effects. That's probably the most solid part of neo-Darwinian theory. The problem is they flip it on the positive side to say that if a positive selection occurs, then they get a bigger arm or prettier face. Well, that's just not being shown. They've shown that we can change proteins to a certain level, but not to the level of building a whole new gene or anything. And that's what we talk about when we talk about microselection. So going back to the Ka ratio, you can now calculate out whether you have neutral mutations or purifying selections or beneficial mutations. And beneficial mutations is basically, that's neo-Darwinism. That's positive selection towards an improved trait, which depends on a better mutation happening. You know, this whole argument has gone on for 60 years, and many biologists said it's crazy to think that a happy amount of positive mutations could fit together to create things to work this way. There's an interesting paper, let me see, Dermot Schmidt, where they calculated out what it would take to have two sequential mutations occur at the same time that were close enough to be mutually beneficial. And they said it would take 9 million years, basically. And if you do mathematics like that, it really proves that the whole thing is just a fool's errand, but nobody wants to do the math. And they belittle people that do the math, and they'll call them a creationist or something else because they don't want to hear about those odds. And yet we know what the odds are. It's simple math. So, okay, so going back to this concept, again, you've got your synonymous versus non-synonymous. And again, you go back to this codon table, you see the protein here being coded for by 4 different okay, so you're thinking, the assumption was then that these synonymous mutations, since the same amino acid came out the other side, that's not harmful. And we can calculate our rates of mutation, we can count our rates of Darwinian selection, whether it's positive or negative. We assumed this for 60 years, basically, based on the genetic code that Francis Crick came out, which I'll explain down here. Now, how important is this concept? Well, I did a quick screen print of synonymous mutations, and this is Pubmed. You can see stretching back to 1971 till today, there's 10,000 articles, and I can guarantee you that there's 10,335, and I can guarantee you that at least 10,330 of those articles all cite the fact that synonymous mutations are inert, that they're not hurting anything. They've all been following the same Pied Piper, except for a few people who are waving their arms saying, hey, that's not right, this isn't working out. And this article, which I accidentally just closed, states that same thing. Open that article. And I'm going to open it inside my DIIGO. So you'll see the annotations I've made in that article kind of focus on it. Do anyone have any questions so far? Okay. Denver, can y'all hear me?
They're like the mutation. They are silent.
That's correct. Okay, the mutations are silent because of the genetic code box, which we saw that different combinations of nucleotides can come up with the same amino acid. Instead of asking the question 60 years ago, why is this occurring? They said, well, it's occurring because it's good for neo-Darwinism. If you think about it, they applied neo-Darwinism, which neo-Darwinism had no idea about this stuff. So they applied a false assumption and said, well, this helps out neo-Darwinism, therefore we're going to look at it from a certain aspect. Instead, they should have said, gosh, this is really weird. You can make several different, the amino acid from several different codons. We really need to be finding if there's some sort of other information we're overlooking, or if the DNA is all there is. And they just kept assuming the same propositions, that DNA was all there was. Does that make sense? Okay, so this is the study that came out just last week, and they went over we talked about the 3-letter DNA units called codons, which describe each of the 20 amino acids that make up a protein. And the fact that going down here in the article, it discusses the fact that non-synonymous mutations are point mutations that alter the protein sequence, that whereas silent or synonymous mutations do not change the protein. You have to change the protein sequence if you want natural selection to occur. You know, if the amino acids aren't changing, there's no change in the protein, is the assumption. But they discovered 1/4 to 1/3 of protein coding sequence point mutations. Well, excuse me, they discovered that about 1/4 to 1/3 of the protein DNA sequence point mutations are synonymous. So, but they thought that these things were just neutral genetic changes, and that's that search that I showed you of over 10,000 articles over the last 50 some odd years saying the same daggum thing. And this, again, this is in light of the fact that we denied the possibility of epigenetics having a separate code sitting on top of the DNA. Now, this article was posted in Nature, which is huge. I mean, Nature's journal, about half of the articles that are read, when anyone reads an article in the science literature, half of the time it's Nature. In other words, the scientists aren't going to read Cell Biology or several other journals out there. They're going to read Nature because it's where it's at. So when Nature publishes these articles, it's something to take notice. They discuss here that the genetic code was solved in the 1960s, and the synonymous mutations had generally been thought to be benign, but now we know this belief is false. That one sentence is just unbelievable, really. The implications are the K over K ratios are inaccurate. And if you can't calculate in a simple fashion what is positive and what is negative mutations, negative selection, then Darwin's selection concept is out the window from a genetic standpoint. You can't say, with just applying simple mathematics to this, and you know, it's kind of suits them right, because it was simplistic math. They thought you could mathematically determine selection on an incredibly complex system that is yet to be mathematically described. In fact, Dr. Coonan said you'll never describe it with a computer. It's far too complex. Not only that it's just complex, it's self-programming, reading and writing. So to have the gall to think that we could take, you know, just the positives and negatives mutations and call that selection was just ridiculous simplicity. And
Doc Mancha,
yeah, go ahead.
I have a question.
Sure.
Now, what are the implications of harmful mutations on Darwinism or on neo-Darwinism?
Well, for one thing, if okay, they're saying here that these synonymous mutations, which were assumed to be benign, and now they're harmful, that basically flips everything from a neo-Darwinian point of view, because here they were using the K over K ratio to assume that something was positive selection, and now in real terms these mutations are bad. So it's almost like you have to get rid of the word synonymous and non-synonymous, which means you've done away with the whole concept of neo-Darwinism on a genetic level. Does that make sense?
Yeah, thank you.
Yeah, so they can no longer write an article and say, well, this shows positive selection or negative selection or purifying selection, you know, because all those descriptions are based upon ratios of mutations of what they thought were synonymous versus non-synonymous. Now, the term synonymous versus non-synonymous is an accurate term, but the tying of synonymous to non-synonymous as being bad or good is completely off the table at this point. They can't say that synonymous mutations are benign because, you know, they're underappreciated. And that's what the article is saying here. They found that 75%, well, we're talking almost 80% of synonymous mutations were significantly deleterious, while 1.3% were significantly beneficial. Now, what is that saying? You know, before with the Darwinian calculations, a synonymous mutation didn't change the protein. So basically it was neutral, what they were saying. But this is saying that almost 80% of these are not neutral, but they're bad. And then what Darwinism is looking for is that positive benefit, okay, where it's positively selected for because it's beneficial. Well, they're saying here that only 1% of them are beneficial. So again, neo-Darwinism is out the window because it's not predicting the right things. Yeah, and the statement down here, the previous anecdotes of non-neural synonymous mutations turn out to be the tip of the iceberg. I mean, when you think about tips of icebergs, you're thinking about Titanic, you know, and here's the evolution ship, the Titanic coming down. It's about to get sunk by this iceberg because you know, we have those 10,000 articles I showed you in PubMed, which are all quoting the same thing. Out of 10,000 investigations, can you imagine the billions of dollars that different governments spend on these biologists at universities, outfitting them with these huge, all their labs and everything, and they're doing these experiments, and they're just following each other by grabbing each other's belt buckle on the rear and just assuming that Francis Crick was correct because he discovered the DNA. You know, it's astounding, really. They also found, they were talking about what goes on about fitness and why this occurs. And they don't discuss this, but it's actually dealing with epigenetics. And there's a couple terms in epigenetics which they have been aware of for quite some time, but they never really talked about the implications of it. One of them was the fact that those codons that code for a particular amino acid, those codons they are biased, B-I-A-S-E-D. In other words, they're not just random, but they're biased. So I'll show you a picture of that. Here's a table showing the percentages, for instance, in different species like human, swine, avian, and the different codon percentages. And you can see by the letters, say for instance, CTG here, that has a value of 1.6, instead of just being 1, it's more prevalent at 1.6 times the amount as the other. So there's this tendency for the RNA to use that particular codon for an amino acid. And they did not understand why that was going on, but what they're discovering now is that it's due to GC bias, which I'm not going to go into. But GC bias is an epigenetic phenomenon. When cells, when there's a mutation in the DNA, the repair mechanisms that go in there will take that mutation and correct it. But in the process of correcting it, it will tend to give more G's and C's of the nucleotides in the DNA strand. And this is called GC bias, and GC bias will drive codon bias, but and this bias is all related to epigenetics. So what we're seeing now is, instead of neo-Darwinism, which relied upon the central dogma and this DNA polymerase being a random mutation throwing machine, to now we're understanding that DNA repair results in biases that are related to epigenetics, and it's not random throwing, it's non-random throwing, and it's biased to a certain degree to lead it towards adaptation in an epigenetic fashion. I will also comment, if you look at the RNA molecule down here, okay, according to the central dogma, by the way, DNA goes to RNA, goes to protein. Well, what if the DNA doesn't code directly for protein? And okay, that means that section of DNA would be considered as junk. That's what junk was. It didn't code for protein. It just is garbage that got stuck in our DNA, and was a great argument to wag in front of the Christians there who thought God made things purposely. Okay, when your DNA has 98% junk DNA, which means it doesn't directly code for protein. It falls outside of the central dogma. Only 2% of our DNA actually codes along the central dogma methodology. But we suddenly discovered that of that 98%, the vast majority of it was coding for forms of RNA called non-coding RNA. The name non-coding, again, means that it's not RNA that's coding for protein. But those non-coding RNA molecules had several different styles and sizes and configurations three-dimensionally, so they could overlay the RNA itself and change the way the RNA interpreted those codons and which amino acids popped out. So basically, we were discovering already that the junk DNA was breaking the central dogma, if you will, because it was causing the codon bias to have different outputs from those codons. That was against the simplistic view of neo-Darwinism, and also basically breaking the central dogma and the neo-Darwinian calculations that they were making. So this is your codon bias sheet. Let me go back to that paper. Okay, so, all right, well, to go back in referencing to this paper, how important is this? It's hugely important. The biggest things, the importance of it is, well, for one thing, it shows you just how detrimental Crick was to genetics and everything. He gets all this credit for discovering the DNA. And by the way, if it wasn't for this lady researcher who died young with cancer, they would not have discovered the DNA molecule. She's the one that did the X-ray crystallography that discovered that it was a double helix. She couldn't finish out her work. She would have gotten the Nobel by herself. She graciously shared the information to them, and they got it. And so there's that story. Not that he wasn't brilliant, not that he didn't deserve the thing, but he was such an ardent atheist. You just have to say this guy was going to do everything he could to prove neo-Darwinian concepts were correct, including coming up with the central dogma, which messed up a generation or two of people, including myself. I thought the central dogma was unbreakable. I also thought the codons and everything and synonymous and non-synonymous was also correct for all these years. And it took the concept of epigenetics and a second code sitting on top of things to understand why this is not the case. So this guy did huge damage in the end. I would not say that it's been good for biology in the long run, but it's actually been more damaging than anything. So again, going back to the things we've discussed, is you've got your different codons or groupings of 3 nucleotides at a time. Therefore, you have a code system based of 64 possibilities down to 20 possibilities. And that seems to make information a downward hill from DNA to RNA, which makes it impossible to go the opposite direction. While true on one level, on an epigenetic level, we can coat the DNA mechanism going back to the RNA with the non-coding RNAs, methylizations through epigenetic mechanisms to change the whole mechanism output. So it's not just a one-way thing. And we've discussed the synonymous versus non-synonymous mutations and the assumptions of this concept all these years, which so many people have believed. We've discussed how it's used in Ka over Ks ratios, that you can take the non-synonymous over the synonymous and come out with a number which tells you whether the mutation is neutral or positive or negative. And therefore, how does that fit into neo-Darwinism? You know, if it's positive, it's neo-Darwinian positive. If it's negative, it's also neo-Darwinian negative. And the same if it's neutral. So they claim all three positions. We saw the simplified version of the central dogma where the mutation occurs at the DNA polymerase. By the way, it was about in the mid-90s when we started noticing that the DNA polymerase that fixes that's working on replication and fixing the DNA errors, that it was having epigenetic input. But now we know that epigenetics is all over the repair aspects. Probably the biggest reason is, if you think about it, your DNA, you've got about 6 feet of DNA in every cell in your body. There's 40 trillion cells. You can stretch it out, put it end to end in space, and it'll go to the sun and back 600 times. That's an incredible amount. I mean, if you got in a spaceship at the highest speed we can do today, that's 500,000 years of travel just to get to the end of our DNA. Okay, that means our DNA is incredibly tightly wound up in our cells. And it's epigenetic mechanisms that do that. Histones, for instance, are these yo-yo looking devices which the DNA wraps around, tightens up, and they're modulated by epigenetics to open up so that you can code from it or close it back up to silence it. When it's closed up, there's no mutations as well, so it's not random mutations. So epigenetic controls every bit of the DNA. Why do these guys want to ignore it? Because it doesn't fit into their theory. As simple as that. Again, we discussed these articles about synonymous mutations, and you notice that there's 10,000 articles, at least that number. It discusses the assumption that synonymous are neutral. And this article basically is saying, since 1971, basically 50 years of biology, we've been wrong, half a century of biology. And that's because we assumed things, and the assumptions that we made were driven by Francis Crick in large part. I think I'm going to pause on that. I think we've pretty well covered that article. Does anyone have any questions about any further about this article?
Doctor, I have a question.
Sure.
Can you tell us the implication of epigenetic discoveries with regards to Christianity, like how God designed organisms, and also the application of epigenetics on Darwinian evolution?
That's a good question.
So we can try to connect that one with our apologetics.
What I'm going to do, okay, there's, excuse me a second. Okay, I was telling everybody that Nature Journal is like the journal, right? Okay, when something comes out and like this, and this was done 8 years ago, you can only imagine that title, Epigenetics, the Sins of the Father. I mean, there's probably some guys that just absolutely blew their mind. Like, how in the world are you attaching biology to the Bible? Okay, so nevertheless, they came out with this article. and called it the sins of the father. In Exodus, right before Exodus 20, right before God tells the Israelites the 10 Commandments, the first premise that he says, he said, if you hate me, I'm a jealous God. And if you hate me, I will visit the sins of the father to the third and the fourth generation. People had struggled theologically with that verse up until today, and they still do. The people that don't know about epigenetics, it seems that God would punish the great grandchildren of somebody who made a particular sin. And how fair can that be? The child wasn't even born. Why would God swack this one because of something that the great grandfather did? So, I mean, that was a hard question to answer for hundreds of years in theology. With epigenetic studies, we were noticing these soft inheritance traits that was ruled out by neo-Darwinian and the modern synthesis, which is a reformulation of neo-Darwinian theory. In it, they specifically denied soft inheritance. And by soft inheritance, I mean things that happen to an adult getting passed on to its children. In the case of mothers, if there was an article that came out just last week that talked about the pregnant women that survived 9/11 are having children with PTSD, which is amazing to realize. But what's going to be interesting is if they follow these kids, their grandkids are going to wind up having the same thing because it goes more than one generation. It tends to be 3 and 4 generations. And they were discovering this in mice models and others. And they were seeing this same 3 to 4 generational aspect, everything. And people said, oh, wait a minute, this is just like the Bible said. And then here's this title that pops out, Epigenetics Sins of the Father. And of course, there's a lot of biologists running around with their brains popping out their ears because of them saying this. Brian Diaz was the investigator that discovered this. And he said he was very mindful of everything he did because he realizes his effects might affect his grandparents and beyond. So now, basically what we're discovering is that there are many different behaviors that can be inherited down the line that can be deleterious, including depression, PTSD, suicide, drug abuse, you name it. And they're discovering more and more that these have an epigenetic basis. Now, why would God command the children of Israel to have 10 basic commandments, simple, straightforward commandments? We all thought, well, these are just good, basic 10 things to do. Why not just do them? As a good civic-minded group of people, we'll follow these big 10 and we're going to be better people for it. Well, that's not the only reason. You have to realize that the Israelites were put into slavery for 400 years. And if that's not a post-traumatic stress provoker, what is? What that first generation that came out, they were incredibly emotional. I don't know if you remember the different passages. They would, they were also happy that they would sing a song the first time they got out, and which seems positive. Then they turn around and build a golden calf, which is totally stupid. And then they were just off the wall, emotionally driven. Moses would leave the camp and they would go nuts. That showed you that they did not have the stability in their minds and in their souls to stay a particular way. And as a result, that generation could not take over the land. I mean, their first reaction when they sent a scout into the new land was, these guys are the Nephilim, they're going to kill us all. They didn't want to go. So basically Moses had to wait around for one whole generation of Israelites to disappear so the next generation wouldn't have those particular traits. And these might have been epigenetic traits, if you will. But okay, so 400 years of abuse, and God takes them out to the wilderness. He gives them purified foods in the form of manna and certain animals to eat. They had very simplistic diets, and which epigenetics can be driven from. And it's possible that what he was doing with them and put them on these 10 commandments was kind of cleaning off all these years of epigenetic errors that were occurring due to the behaviors and being traumatized. And that's just a theory I have, but there's nothing absolute about that. But it has a predictive aspect to it. You can also take this concept of epigenetics and go backwards in time to the garden in Genesis. For instance, the question I have is, what if Adam and Eve were in the garden and they did not have the tree of lives? Would they have lived indefinitely? And I believe that they would not have. I believe the tree of lives was a resuscitative fruit that had elements in it that helped the epigenetics of the humans, Adam and Eve, so that they would live longer as long as they had access to this plant. And the assumption is that they did eat the plant. God told them they could eat the plant. Eve was a very curious creature. She wanted to eat the other plant too. So you can be assured that she definitely ate of the tree of lives. You know, the assumption that a lot of people make is that all the, you know, when God said, you know, you can't eat of it now or you'll live forever, everyone thinks that, oh, if they eat of it just one time, they'll live forever. No, I would say that the assumption is they were continuously eating of it when they were in the garden. And then when they were put out of the garden, they could no longer continually eat of it. And then more and more epigenetic malfeasances occurred. So that's one of the things that we're learning about epigenetics. It has the ability to, the predictions of our age, according to a concept called the epigenetic clock, are very accurate. And epigenetics is probably going to be the avenue to prolong human life. In fact, I mean, there's a rumor amongst the medical folks that we may have people living 150 years within the next 10 to 20 years. We've already done experiments in mice using thyroid hormone, metformin, both of which I'm on, and growth hormone to increase their life expectancy by at least 20 human years in equivalency, which is phenomenal if you think about it. So subsequently, I think that the original sin that occurred back in the garden had two levels to it. On a spiritual level, it was a rejection of God's plan, His grace, in a matter of pride, thinking that they were equivalent to God. That was the temptation that Satan told her. You know, if you eat of this, you'll be like God. And if you recall, and that's exactly Satan's sin as well. He said, "I will be like the Most High God." That was his arrogance due to his beauty that caused him to fall. And it was the same one that he used for Eve to cause her to fall, only with his help. He said, if you eat of it, you'll be like the Most High God. Okay, so man and Eve, Adam and Eve were put outside the garden. And then God said, you know, we're not going to let these guys eat of this tree, or else they'll live like us forever. And you have to ask yourself, why did He not want them to live forever? And I would submit to you, it's because we don't want to live forever in a state of sin. Because over time, we'll become more and more sinful, to where if you're living several hundred years, you become incredibly cold and sinful, basically. Yeah, that was the prediction, and it in fact wound up being the case, because the Noetic flood group of people were intermixing with the angels. They were probably very violent, probably mass murders were occurring. They were probably torturing animals and all the things like that, and they were wiped off the face of the earth. So we have epigenetics possibly affecting the age of things. Now there's this question about is the sins of the father something that is different from the sins of the mother? Because it does discuss in Exodus, the sins of the mother are passed on as well. But biologically, when you look at the difference between males and females, it occurs more with the males than any kind of epigenetic errors. And that's interesting to me because I wonder if the sin of Adam, basically the physical aspect of the sin of Adam, not the spiritual aspect, is it due to the fact that there's a difference in the way sperm develops versus the eggs? And I think that there is. And now it kind of explains the way things are better. Whereas we tried to explain in the past, it didn't make sense from a Mendelian standpoint that something could be passed on genetically. But from a non-Mendelian aspect, it can work. And so it's very possible that epigenetics is the part of the genetic aspect of Adam's original sin, but it's tied still to the spiritual aspect of the fallen state of man. So that was a long answer. That do it for you. Denver.
Thank you, Doctor.
Okay.
Thank you, brother. That is
Did
a
we
great
want to
answer.
go? Do you want to go on to the next question?
Brother RC has a question. Brother RC, do you want to open your mic or do you want me to just read? Okay. He has a low internet connection, so I'll just read it. So this is his question. Wait for a while. Can we attribute epigenetics to prove assumptions that real humans, the descendants of Adam and Eve, procreated with Neanderthals, like William Lane Craig and Swamidass implies?
Well, in fact, I wrote I posted this. Okay, I've told you about Darwin versus Lamarck. Do a search here. So, okay, here's my Facebook feed, Darwin versus Lamarck, which this is a good resource, by the way, because I've written on many of these topics, like the one that you just asked. Okay, what happened is I write a lot for Quora. I've got about 4 million views on it so far. And there's this, I wrote this article, How Does Neanderthal DNA Affect Those of Us Who Have It? And you can find the article either on Darwin versus Lamarck or looking it up in Quora. And this is the answer that I gave. The better answer is how does Neanderthal epigenes affect us? And I say again that gone are the days of neo-Darwinian measuring pounds of similar exonic DNA, which makes up only 2% of our DNA. The exonic is the protein, it's the protein coding section of the DNA. See, due to the modern synthesis, only the coding part of the DNA is considered to be evolving, but the rest of our DNA was junk. And I went on to describe what a snafu this was. And I said a better way to look at how things go is DNA going to exonic, which is at 2% DNA, and junk DNA, which is a 98%, which also goes to RNA, that's the messenger RNA, which we talked about in your vaccine, and non-coding RNA, which comes from that 98% junk DNA. And it rewires how things come out without Darwinian mutations. Okay, so this does away with Darwinianism. Back to the Neanderthal. The Neanderthal shares about 1 to 4% of that 2% exonic DNA with us. So when people talk about us being related to Neanderthals, it's very possible that through bestiality, somewhere along the way, there was some intermixing between humans and Neanderthal. There's a good bit of argument on this, but at best, if there was some possibility if you take our 2% of our DNA and then take only 2% of that, you're down to 0.04% of our DNA matching with Neanderthal. Okay, that's hardly much DNA if you think about it. It's certainly not enough DNA to explain how they look differently. Their shapes of their skulls and their arms and everything. Okay, so they decided, hey, why don't we look at the epigenetics? And more specifically, the epigenetics of what's called the Hox genes. Hox genes are the genes that guide your body plans. So if you draw a line from the top of your head down to your toes in the middle of your body, it's symmetrical. You've got 2 arms, 2 legs, everything. The Hox genes code for that symmetry of those different organs. So just about every body plan of animals has these Hox genes. And they studied the epigenetics of these Hox genes, and they discovered that the Hox genes between the DNA that came from Neanderthal and from man was strikingly different. Okay, so they basically discovered why we look so different than Neanderthal, even though we only have 0.04% the same DNA. So DNA is not the answer. It's the epigenetics and how the epigenetics plays the DNA, in this case, the Hox genes, to make things different. If you see the statement here, they discovered that in the Hox genes, there's upwards of a 60% difference in epigenetic tags. So that's what's making the explanation of things. These sort of experiments are coming out everywhere. Darwin's finch is a perfect example. Dr. Skinner, also about 8 years ago, studied the mutations in different finches on the Galapagos, and those mutations did not orient towards the different genes that were coding for the beaks, etc., but epigenetic tags were. So the epigenetic changes were what was causing these, the change in Darwin's finches, which is a major slap in the face to neo-Darwinism, because the finch was his foundational principle upon which he built his theory. And in fact, the change is not through natural selection, it's through epigenetics. So, and this is a statement that right here that's important to understand. We, all animals basically share at least 90% of the same exons, or that 2% with others. And to explain how, and also it's not important the amount of pounds of genes different, how epigenetics uses that small amount of exonic DNA. And to make explain that, assume you want to build a house. You can have 2x4s, windows, etc. And exonic DNA makes them, right? But the junk DNA by epigenetics can shape them in numerous forms. You can make a church or a building or a bank with the same essential ingredients. You can make a high-rise building. The only difference was you wouldn't have the I-beams. So that would still not be that different. But if you go in a big building, it's got the same doors and everything that your house does, doorknobs, etc. Okay, all those basic building parts are the exonic DNA. So as a result, we are all given a basic toolbox of DNA, and the DNA is a passive agent. It's the epigenetics which plays the non-coding RNA that's the builder. And that's how we wind up being different than the Neanderthal. Does that answer that question?
Thank you, doctor.
Okay.
I think that's great.
Okay. Well,
Brother RC said he get it well.
So you can find that on Darwin versus Lamarck group. Just join in and you can follow these things that I'm posting. And then again, if you want to search for a particular concept, because I've written so many different things now, you can actually search the everything in there about this. Okay, I'll move on to the next.
Question.
Oh, go ahead.
Question. I don't know if this is beside the point, but would like to ask Dr. Mancha if are junk DNA argument for or argument against intelligent design?
Well, it's an argument against intelligent design as put forward by Richard Dawkins and others, but it's an argument that blew in their face. And now it looks like, it's not just looks like, it shows just how bad neo-Darwinian reasoning was. Because according to going back to the central dogma, Francis Crick's central dogma, for something to be valuable, you have to have protein come out the other end of the machine. DNA goes to RNA to protein. Why? Because that protein makes a bigger arm or stronger muscle, a prettier face. And then that person gets to mate more and pass on their genes, survival of the fittest. If you don't code for a protein, if it's non-coding like junk DNA is, then it is junk. It has to be junk according to the neo-Darwinian model, right? That was probably that singular mistake is the biggest snafu of neo-Darwinian theory because of their basic assumption. And so what's fascinating about that, though, is the Discovery Channel, and Wells was his name, Jonathan. He actually wrote a book, which I bought, about the myth of junk DNA. And several, he and a couple others who were in that organization were predicting ahead that this was going to be valuable stuff, that it's not junk DNA. Before the biologists were doing. I mean, the biologists should have been predicting this. They should have been predicting this long before anyone came up with this post hoc explanation of what seemed to be useless. They should have been from the beginning. In fact, Francis Collins, the head of the Human Genome Project, who ignored the junk DNA, he later said it was the height of hubris to think that this stuff had no effect at all. We're discovering it all has an effect. So why didn't he have that same, sense of why isn't this important? Because he was willing to ignore stuff based on a bad theory that he personally strongly still believes in. He doesn't get back and say, Darwin just blew my study of 11 years and $7 trillion with, why am I going to give my homage to this guy? But he still wants to believe it. So, it supports intelligent design better than anybody because they were the first ones really to say this stuff is of effect, it's good. And they've been vindicated in a big way.
Okay, Doc, thank you so much. Can I ask another question?
Sure.
What does epigenetics say on the fact that we share 90% similarity of our DNA with chimpanzees?
Well, okay, the Neanderthal article I just pointed out, there's also an article, basically the same model applies, right? The same model applies. Everyone's given the same basic toolkit of exonic DNA, that 2%, and it's the 98%, which is the junk DNA that makes the difference. This is an article, which is a lay article, and you can find it by just typing in chimp under Darwin versus Lamarck, and it answers your question completely. It's human and chimp brains differ in non-coding RNA regions. That's the junk DNA. It says in a new study, stem cell scientists in Sweden explore the non-coding regions of the genome previously deemed as functionless junk DNA, not under natural selection, and find humans and chimpanzees use a part of their non-coding DNA in different ways. So that's basically, again, you have that 2%, which is only codes for proteins, but then you have the 98%, which tells the 2% what to do. And again, neo-Darwinism threw the 98% out with the mouthwater. I mean, huge. That's, again, you divide 2 by 98, that means 49/50ths of the DNA code they threw out the window as being not important. Have they lost their minds? I mean, and why? So that they could somehow bend neo-Darwinism to genetics, you know, and come up with convenient things like K over K ratios, which have been proven wrong for the last 50 years, and assumptions like synonymous versus non-synonymous. It's madness. Their religious commitment to a stupid theory is a complete waste of time, and they just simply don't get it. But they keep regurgitating the same things over in the colleges. So basically, in this article, it goes on to talk about how the junk DNA again, opening up my DIIGO so I can see the highlights real quick, and we'll discuss a couple of them. How it was the junk DNA that's coding. Okay, look at their statement here. Despite significant similarities in our DNA and few differences in the protein coding genes, the human forebrain is larger. Now, I don't know if y'all remember, but for years, the evolutionists were hitting us on the head by saying, well, you know, chimps are 98% the same DNA as us. Therefore, we have come from chimps. Well, you know, we may be related to chimps in the past. That's an unresolved issue. But the 98% argument does not work anymore because it's 98% of 2%, which means the vast majority were very different in, and you guys were ignoring it because it was proton coding. It was junk DNA. So they've discovered a particular gene, this one here, that's expressed in humans but not chimps, and it regulates expression of a family of transposable elements. Now, guess what those are? Those are junk DNA. Our DNA is made up 50% of them are transposable elements, and they have no idea where they came from. They look kind of like viruses. Maybe they were very, very ancient viruses, but we don't know. But nevertheless, they're part of that 98% stuff, which is junk. And now we're discovering that this transposable elements, which are often just repetitive and they look like junk and clutter, are doing things in ways that we could have imagined. And so this has got everybody like, whoa, what is this going on? One of the big questions that comes out of this is because these transposable elements, when they do phylogenetic studies, they have been around for millions of years in primates, but they're suddenly taking on new form action. Like, okay, so here's this element that was just sitting there doing nothing, presumably, and then suddenly it's causing some action. In the case of primates, for instance, the placental building aspect is significantly guided by transposable elements. In fact, not just transposable elements, but endogenous retroviruses. A virus that got stuck in the DNA perhaps millions of years ago suddenly is doing things to change primates in order to have babies. That is completely insane from a neo-Darwinian point of view, because neo-Darwinianism does not see into the future. Evolution is occurring right then and there, and it can't predict that it's going to be a need millions of years in the future. Creationism, on the other hand, can do that because it has the view that God can put a piece of DNA that's going to be used in the future million years ahead of time, and then it might be subjected to particular factors so that it will suddenly come into play at just the right time. You know, so a common design element, in other words. But in any fashion, this article is basically the same thing as the about the same basic reasoning as the Neanderthal argument. Okay, the 98% is what's causing the difference. In this case, the humans and chimps have a much greater difference in the brains of the 98%, and that's explaining why things are different, even though the 2% looks almost identical. But you know, our 2% DNA, the exonic DNA, we're 97% the same as a mouse. But do we look like a mouse? No, but you got to ask yourself, do mouses have ears? Do they have a nose? Do they have feet, toes? Yes, they do. We do too. But they're very different looking, but nevertheless, they are of these things. Ergo, those are the things that the Hox genes code, and our Hox genes make us have different shaped arms, but they're parallel on both sides, and it makes mice have different arms, etc. And so that is a big difference. The epigenetics shapes how a gene is played to make many different things, and that's what. So does that pretty much handle that?
Yeah, thank you so much, Doc.
Anyway, doctor, just a little bit, just a little add. With regards to endogenous retrovirus, during my course in molecular genetics, I made a term paper regarding endogenous retrovirus. So I tried to look at the literature really, and some of them really perform very important functions such as brain development and like the one that you mentioned, placenta. But aside from that, I was also able to find functions from other group of animals and not just humans. So it's really interesting. Although I still think that it's evidence for common ancestry, nevertheless, they're not really that junk DNA.
Well, here's the thing: endogenous retrovirus is cut both ways. If you're gonna take the Darwinian argument that they're junk DNA, well, you've already been disproven in a big way, because they have design features. But on the other hand, from a Christian standpoint, it does raise the possibility of common ancestry, because it would be like looking at your computer hard drive, and there's stripes of the same stripes occurring on the same part of the drive over and over again, multiple times. It really does seem to imply common ancestry, because primates share some of these very similar things, but also other beings like chickens and cows and others have these common elements. So that does make it an open question. I think the thing, though, that we have really not fully recognized yet is, what is our microbiome, the bacteria in our intestines, doing to cause these? Are they causing endogenous retroviruses to get placed back in our DNA at certain times over the vast periods of time? And we are now just starting to address that question. In other words, these endogenous retroviruses typically come from prokaryotic bacteria, and most of those are in intestines. I mean, we have at least 10 times the amount of bacterial DNA as we do human DNA. And so these viruses that are in these organisms could be getting into our DNA to cause a lateral transfer of this information. But since the geneticists just kind of took these endogenous retroviruses only as a evidence for their point of view of common ancestry, they really didn't look into the rest of things. And so now we're here's an article that I noticed about this. In the case here, we have a woodpecker and a snake having the same endogenous retrovirus. So you got a woodpecker man and a snake man here, both having the same endogenous retroviruses as their. So when you try to make up trees, common ancestry, it makes it difficult to do that. The same thing has occurred dogs. We have one of the endogenous retroviruses, a dog. So you call us a dog man if we're going to follow strict phylogeny trees. They were assuming all this time that endogenous retroviruses established as they do not reinfect other lineages. Now that's being shown wrong. In higher, it was believed that the lateral transfer does not readily occur with the exception of retrovirus infection. However, they say our results provide compelling evidence for horizontal transfer of genetic material that has transformed. And what they mean by horizontal transfer, and that says bacteria in the body. See on the bottom right here, we've got ticks that can transmit it, rats and others, and they're moving this stuff around, and the DNA is moving between our microbiome and our cells, and it's reshaping our DNA. Until we really explore all this, we can't really make these conclusions that this stuff is just stuck in our DNA in one spot and it occurred millions of years ago that it hasn't moved. That's a bad way to look at things. Also, when they try to do phylogenetic trees, how long they've been there, they're discovering that their phylogenetic trees are inaccurate. So this whole, here's an interesting one here. They used endogenous retroviruses to determine phylogeny. They concluded we were ancestors of the gorilla. That's what we've always assumed. However, when they studied the human endogenous retrovirus K, HML2 endogenous retrovirus, it was in humans much more than chimpanzees. And if you come down here, they also noticed basically they were finding them in mice, and where else were they? So basically, what that says is that this phylogeny tree was not holding up because I think it was chickens were showing this particular endogenous retrovirus before the gorilla rather than the gorilla to the man. In other words, the tree was not holding up. And as you search through the literature, you find more and more things like that. I find it is one of the most compelling arguments for common design, for common ancestry, but it's also one of the most common arguments for common design. To think that God made chunks of DNA that was able to rearrange itself through moving through different parts of the genetic system in the form of transposable elements indicates to me that there's a common element of design through all this. So that would be my argument to it. I would just say it's kind of like the Zen master. We'll have to wait and see. By the way, if everyone has not read this article right here, I really recommend that you read it. It's called "Do We Need a New Theory of Evolution?" And it was written by The Guardian, and it's very good. It does not mention the word epigenetics directly. Maybe it does, but what it discusses is the extended evolutionary theory, which includes epigenetics and how we need to go to that and how the old theory is out. And this is an article you can send to your friends and post on Facebook. It's really you can't argue with it too much. I mean, the people that disagree with it have not really produced much of a convincing article because they did such a good job of covering all sides. Any other questions in the moment? Okay. What time do we start? We've been an hour and a half in. How's everyone for time? I mean, I can keep going. I've got another article I can present, or we can just keep answering questions. Denver.
Yes, I
Yeah.
think there are no questions yet.
Okay, does everyone want to go to another article or how you want to work?
I think I have a question, Doctor. With regards to what you said on GC bias, right? That mutations are biased for GC. Does that mean that we have more GCs in our bodies than ATs in our
No,
genomes?
no, and this is an interesting question. Why in the world is there, well, okay, number one, the spontaneous bias, which is called mutational bias, when they haven't really gotten a standard term for everything. But when you say mutational bias, you're actually talking about AT bias. And what that means is that the cytochrome, which often is methylated due to epigenetic mechanisms, it spontaneously will throw off the methyl group and wind up being translated into a T. So there's this, and this occurs over hundreds of thousands of years that this increase in that AT bias occurs. However, what is interesting is when a mutation occurs, like a single point mutation, and the DNA mechanisms go in there to repair it, it tends to repair with a predominance of G's and C's, which is called the GC bias. So you have the AT, which is causing a downward slope, and then you have the GC, which is causing an upward slope. And it's going to be something between the two seesaw actions of those that causes mutations. So instead of a neo-Darwinian view of mutations as being just a random process and maybe some good ones get together, it's a teleologically derived cellular mechanism that's doing this over hundreds of thousands of years to create a balance of these different mutations, which is, so, but the GC bias tends to wind up putting more G's and C's, and it's not spread out evenly. It's different in certain parts of the genomes, specifically in the CPG islands, which sit in front of the genes. There is this increase in the CG bias, and that tells the gene when to code and not to code. Also, in a sense, this CG bias drives the codon bias that you saw in that particular table. So basically what we're talking about is epigenetics once again explains genetic phenomenon which replaces neo-Darwinian concepts. When they were doing the ratio that I mentioned, what is the ratio up here again? The K over K ratios, they were noticing that particular ratios were causing a negative purifying selection. And they were describing it mathematically and saying, well, this is purifying selection that's going on based on those ratios. But then they realized that GC bias is causing, in essence, the same ratios. Whereas their assumption here is that this is due to those codons being completely random, which is incorrect, which that 60-year theory is incorrect. You can't just say that's purifying selection, not if there's a mechanism. And the mechanism of GC bias is the cellular repair mechanism is causing that. And therefore, instead of saying this is purifying selection, you need to say this is GC bias, because mathematically they look the same. But from a mechanism standpoint, you have a mechanism, whereas purifying selection is just a ad post hoc conclusion of trying to apply neo-Darwinism to genetics. And it's a lost concept, really. So I hope that makes sense. But in the long run, basically, GC bias produces codon bias is the main thing to remember. Mutations are not random. And that's another article which I put on my Darwin versus Lamarck page in January. A Nature article came out and said for 100 years we thought mutations were random. Now we know that they're biased. And that was another nuclear bomb. okay, 2 nuclear bombs like that within a 6-month period is unheard of. 60 years of neo-Darwinian thought have been dismantled in a period of 2 months and in a period of 6 months. That's huge. All these concepts are popping out as a part of epigenetics because they realize epigenetics really explains what's going on. It doesn't need assumptions that neo-Darwinian evolution makes.
Yes, yes. Thank you, doctor. And also, I think with regards to Darwinian evolution, because of the new study that you presented, like the deleterious synonymous mutations, I think that would be harder for evolution because that would mean that um, there is a higher degree of mutations that is harmful, right? Compared to what is expected before, that they thought that
Well,
most are neutral.
yeah, you recall that when they discovered the genetic code, Francis Crick famously called it a frozen accident. And that's what we were stuck with for 60 years. Like, why are these codons reading the way they are? He said, well, it was just good. And it was an accident and it was frozen. It just got stuck. And that term got stuck. So his frozen accident concept, which really had no basis for understanding, just has driven us to make just false conclusions. So that's part of the damage this guy has done to make terms like frozen accidents. That's an ender as far as looking further. That doesn't mean people didn't research it, but ultimately they just said, I'll throw in with the frozen accident, and all these articles which I showed you, 10,000 on synonymous versus nonsense, probably just about all of them quotes the frozen accident of genetics. So we should have been asking, why in the world is it that we have multiple codons coding for one amino acid? And is there other information that we're not aware of? Because that would explain a lot of things, but they didn't look that way. So they didn't find it. What they were unwilling to look for, they would not find. Is basically what happened. So the DNA code became a frozen accident that was degenerate. The reason it's degenerate is because several different codons can make the same amino acid. And they also assumed because of that, if we combine it with neo-Darwinism, well, that makes a convenient way to come up with a synonymous to non-synonymous ratio, and we can calculate it all day long. We can count mutations and calculate and publish articles that say Darwin did it. And I mean, there are hundreds of thousands of articles that use this ratio, but that's how bad this is. I mean, this is simply blowing the doors off the barn. All these basic models, which we learned and believed, are out the door. And so it's astounding. It's truly astounding to be, I would say, in biology right now is exciting. It was boring when I was in college. We just accepted these assumptions. I knew something was wrong because of the complexity of things. And I asked the question myself, how in the world did this start? Just that alone kept me somewhat insulated from a lot of the evolution. And I just studied and I gave them the answers they wanted. So I get my A and go to med school. So.
Oh, see. Thank you, doctor. So far there are no other questions yet. But I'm just wondering also, what is your view on Genesis? Do you believe that maybe God created everything through epigenetics, or do you believe that He really intervened on the organisms, something like that?
Well, Lamarck famously, he said in his book that God, if he's so powerful to be able to create, he can create a couple things, like a couple organisms with the potentiality to become others. And that statement is amazing when you think about it, because in essence, that's what we're discovering. These transposable elements and the epigenetics can cause differences in chromosomal patterns. There's an article I just read couple days ago showing that they're able to take a mouse and double their certain chromosomes, which is huge, because until we learn how to pair up chromosomes in different ways to cause different speciation, we can't figure out speciation. Epigenetics imprints those chromosomes so that you can do that. So now, as I'm a progressive creationist in the sense that I believe that that the Holy Spirit, when he was on the surface of the water in Genesis, that he was not just on the surface of the water, but that he was probably creating first life at that point, and it was probably bacterial. And the reason he created bacteria was because bacteria is very hardy, and it can change the earth. It can terraform the earth. It can take, carbon monoxide and metals out of the atmosphere. But he gave it the potentiality to trade DNA between each other through horizontal gene transplant, and to change into other things. Now, when you look at Psalms 104, it says that it says that when God takes away the food of the animals, they scream out and they die, and the Holy Spirit comes back and repopulates the land. That sounds exactly like mass extinctions. And when you look at mass extinctions, suddenly there's this plethora of new life. I believe it was a creative thing that occurred. I believe, though, that the Holy Spirit used the materials that he had already created at the very beginning. And that would include a lot of the transposable elements, because transposable elements are like subroutines that can go and add in front of genes to cause them to do different things. So whether it was all by naturalism that this occurred, I asked Dr. Hugh Ross one time, is it possible that life was multi-potential at the very beginning? He said, yeah, it is. I don't think he really pushes that. He doesn't. He pushes that there was more interventions throughout history. And I don't think anyone can know that right now. And the reason we can't is because we can't do the phylogenetic studies on transposable elements. They disappear into a web, in essence. We can't get a tree out of them. So they're like a web of horizontally elements that move around, and we don't know exactly where they arose and how they change things. But the general consensus amongst biologists is probably that horizontal gene transplant of transposable elements is maybe what caused these mass extinctions to repopulate everything. And they may be, in fact, describing what the Holy Spirit did. So that's my opinion on it right now, but it's completely theoretical.
Thank you, Doctor. Do you want to continue, Doctor, or maybe we can have the discussion again next time? Because it's already 10 here in us.
Yeah.
Almost 10.
Yeah, we can just do this another time. Why don't you and I schedule for about a month from now? We can do this again.
Yes, Doctor. Some of my classmates really find the discussions very interesting, actually.
Yeah, we can
Yes.
just stick to discussions if you're.
Yes. So maybe
we'll truncate it down next time. Just do like one important article, and then we can talk about different stuff.
yes, that's really great.
Okay. All right, sounds good. And I'll make a copy of this recording. I'll spin it up to YouTube and share it with you.
Okay, Doctor.
Okay, and we'll get together on the next time. So everybody that's listening, y'all connect up with Denver. Join my group, and you can post questions, by the way, in that group. So during your lecture, in fact, okay, I announced this meeting in the group, right? So what you could do is say you have a question that you didn't get answered. I thought I put. Okay, here it is. I'm conducting a Zoom meeting for Rancho Christi, Philippines. So y'all can come down here and put a public comment, I enjoyed your meeting, can you, and then put your question there. Or you can just post it right in the front part of it. Just come down here and write something and say, I've got a question about something, and I'll answer it. So I think that's the best way of approaching it, because that way it's public to everybody. We're not just emailing each other. All righty, and then y'all give feedback to Denver when y'all want to meet again, and we'll set up a meeting in the next 2 to 4 weeks. All right.
Yes, Doctor. Thank you very much, Doctor, for the time.
All right. Okay, you're welcome.
Really enjoyed it.
Okay, take care now.
God bless, Doctor.
Bye-bye.